In this lecture, we'll take a look at a visual example of steel reinforcement. Here we have a simply supported singly reinforced concrete beam. It's subjected to a uniform loading that we call W. The dashed line is the deflected shape of this beam under the uniform loading, and based on this we can see that the top half of the beam is under compression and the bottom half is in tension, and bending is about the neutral axis, which we will show momentarily. To understand the stress and strain occurring on this beam, we have to take a look at a cross-sectional view. So to the very left is a cross-section in which B is the width, B, and D is the distance from the extreme compression fiber to the centroid of the longitudinal tension reinforcement. And A sub S is the cross-sectional area of the steel reinforcement and can easily be calculated using the formula of pi times the diameter of the steel reinforcement squared divided by 4 if we know the diameter of the steel reinforcement. So this beam is called singly reinforced because reinforcement is only on the tension side, which is the bottom. If there was reinforcement on the top or compression side, this beam would be called doubly reinforced. To the right of the cross-section is a strain diagram, and NA is a neutral axis, which is the axis about which bending occurs. Epsilon C is the strain of the extreme concrete compression fiber, epsilon C. And epsilon S is the strain of the steel reinforcement. To the right of the strain diagram are the stress diagrams at a particular point of loading here, and at failure. Here's a failure stress diagram. F sub C is a maximum compressive stress on the concrete, and F sub S is a tensile stress on the reinforcement. Here's F sub S. And finally, on the furthermost right side is a simplified representation of the forces, where we have distributed compression forces on the concrete that we call C, and tension force on the steel reinforcement, which we call T. And notice that we're assuming that all of the tension force is being taken by the steel reinforcement, and that is the purpose of the reinforcement. Even though there is some tension load on the concrete below the neutral axis, but for simplification, we just say that all of the tension load is taken by the steel reinforcement.